All right, guys, this is polynomial long division, which is kind of cool because we learned long division probably when we were in maybe 4th or 5th grade, but now we get to apply it to polynomials. So it's really the same procedure, just with polynomials. So now we're going to have variables and expressions that we're dividing. So I just want to review a little bit of vocabulary. First of all, the word quotient. Okay, hopefully you remember the quotient is just the answer to a division problem. So the answer to and I'm just going to write the division sign problem. And a couple other words you should know are dividend and divisor. So in this problem, consider the division problem 1,519 divided by 7. The 1519, okay, the thing that you're dividing is called the dividend. And the 7 is what we're dividing by. And this is our division sign, remember? The fraction bar is just a division sign. This is called the divisor. Okay, so some vocab words you should be familiar with. Quotient, which is the answer. The dividend is what you're dividing into, and the divisor is a action word that's doing the dividing. All right, so basically it wants us to find out if there is a remainder. Okay, is there a remainder for the division when we divide 1519 by 7? Okay, oops, I'm just stay in the picture while I do this. All right, so I have 1,519, and you might want to write small. There's not tons of room here. But remember when we divide by 7 with long division, we say, okay, does 7 go into 1? No. Okay, 1's too small. So now we say, does 7 go into 15? And yes, it goes into 15 2 times. So then we do 2 times 7, which is 14, and we subtract. So 15 minus 14 is 1, and then we bring down the next number, and we repeat the process. All right, does 7 go into 11? Yes, it goes in 1 time, and 1 times 7 is 7. 11 minus 7 is 4. Okay, we bring down another number, and we now ask ourselves, does 7 go into 49? And yes, 7 times. So what this means is, you see there's no remainder. So what that means is that 217 is our quotient. That's the answer. And since there's no remainder, that means that if I were to split 1519 into factors, 7 and 217 would be 2 factors of 1519 because they divide evenly into 1519. All right, so now for part B underneath, it says to rewrite this as an equivalent multiplication equation. All right, so since 217 and 7 are factors, that means when I multiply them, okay, when I undo the division by multiplication, I use the opposite operation. This is a way to check my answer, right? So 7 times 7 is 49. 7 times 1 is 7, plus 4 is 11. I carry the 1. And then 7 times 2 is 14, plus 1 is 15. And basically, I can check my answer. So you can check your answer with polynomial division. Also, if you just multiply the quotient times the divisor, you should get the dividend. Okay, so the quotient, oops, I forgot the U. And this is important that you know you can check your answers. Quotient times the divisor equals the dividend. That's an E, dividend. Okay, so now it says, does 1522 or divide 1522 by 7 by long division? And in this case, we will have a remainder. And if you think about it, if 7 goes into 1519 evenly, we would have to add 7 to this, okay, to get 1526 to get the next factor of 7. So I know that there should be a remainder, okay? And if you think about it, you could tell that the remainder is going to be 3, right? Because 1522 is 3 bigger than 1519. But it wants us to go through the motions, and we'll see how it works when we have a remainder. So, oops, I'm going to put the dividend underneath my division bar. The divisor goes here, and it's the same procedure, right? 7 goes into 15 twice, we have 14, In this case, we have 7 into 12, which is ones. Okay, we're going to multiply 7 times 1. 12 minus 7 is 5. We're going to bring down the 2. It's still going to go in 7 times, but now when I do 52 minus 49, I get an extra number 3, right? It doesn't go in evenly, and there's nothing else to bring down, so 3 is my remainder. So it says to write my answer in A plus RB form. So it goes, the quotient is 217, okay, plus, actually I'm going to write this form first. If we have a remainder of 3, that means it's 3 out of 7 remaining, okay? So when we just have regular numbers, we could just write 217 and 3/7 as a mixed number. But when we have polynomials, we're going to write it like this. I'm going to leave it in this form. Okay, another way of writing it, and that's this form that I probably should have written the first time, is just 217, and then we use a capital R for remainder, and there's a remainder of 3. Okay, so this form looks like this, and this would be the other form. Okay, and when we deal with polynomials, you'll probably see it written in, this is called quotient plus remainder, okay, over divisor. All right, that's the form we're going to write it in. And we can also write as an equivalent multiplication equation. So in this case, again, we do the 217, if we want to check our answer, times 7. I'm just going to steal my answer from over here, right? I already know it's 1519. And then what I would do is I would add the remainder, okay, to get 1522, and then check. So now it's quotient times divisor plus remainder would equal dividend if there's a remainder. So basically, now I do quotient, okay, times divisor, and then plus remainder if there's a remainder. And that would equal the dividend. And I'm just writing it like this. Obviously, you wouldn't set it up like this. You would really do this. There'd be another line there. You get the answer, and then it'd be, that's how you do it. Okay, so anyway, now we're ready for polynomial division. And I'm going to scroll down here, and we're going to do the same way. Okay, so the first thing we're going to do is we're going to check to see if we have a complete polynomial, it's called. All right, this is a second degree polynomial, and then I have a first degree, and then I have just a constant. So no terms are missing, okay? We're going to talk about that later in this lab, where we need to make sure we have complete polynomials. Okay, so in this case, we have a complete polynomial, so we don't have to worry. I'm going to take my trinomial of 2x squared plus 15x plus 18, and I'm going to divide by x plus 6. Okay. Did you add? All right, so when we're dividing the x plus 6 into this trinomial, we're going to want to first divide it not into this just this monomial 2x squared, but we're going to look at the binomial 2x squared plus 15x. And we want to make sure the first term we bring down, okay, we're going to end up multiplying x plus 6 times a value. And when we multiply by x plus 6, we want our first term to be 2x squared. Okay, so in order to get a 2x squared, we have to multiply this first term x by 2x. So I'm actually going to put a 2x here, and I'm going to distribute that to the x plus 6. So 2x times x is the 2x squared. That's what I have to have. I have to have these first terms matching. And then 2x times 6 is a plus 12. And I'm not concerned that the second term matches. I only want these first two terms to match. Okay, now I have to subtract this binomial. Okay, this is where a lot of students make mistakes because they forget to distribute the negative. But basically we're doing 2x squared minus 2x squared. These will cancel out. And then this minus sign also applies with the x term. So it's 15x minus 12x. Okay, I don't want to put another sign there, but 15x minus 12x, which is 3x. Okay, once I'm done subtracting, I bring down the next number, and this happens to be 18. All right, same thing. Now I want the value up on top, where if I multiply it times x, I get the first term that I'm dividing into, which is 3x. I'm just going to draw a line here. So I want this to be a 3x. So in order for that to happen, I have to multiply by a positive 3. Okay, so I'm going to take that positive 3, and I'm going to distribute to both pieces, the x and the 6. So 3x, 3 times x is 3x, and then 3 times 6 is 18, and I am going to subtract it. Okay, so I'm taking a value and I'm subtracting itself. So obviously this would be 0, and there's no remainder. So what that means is that my quotient is 2x plus 3. This is the quotient. And since there's no remainder, that means 2x plus 3 is a factor. Okay, it goes evenly, it divides evenly into our dividend of 2x squared plus 15x plus 18. Okay, now it says to rewrite it as an equivalent multiplication equation. So basically what I'm going to do is I'm going to check my answer by multiplication. Okay, and we know we take the quotient, which is 2x plus 3, and we're going to multiply it by the divisor, which is x plus 6. And when we multiply by polynomials, we set it up like this. So I'm going to double distribute, and I'm going to get 2x squared plus 12x, and then distribute the 3 to get plus 3x plus 18. And when I combine like terms, oops, I get 2x squared plus 15x plus 18. Okay, so it's that easy. Okay, it's that easy. All right, so we're going to do the next part, part C. Bring this up, bring this over here. Get myself set up here. Okay, so this is another division problem. It just wants me to write it in this form. Remember, Q of x just means quotient, R stands for remainder, and in this case, Q of x is going to be a polynomial. R is just a constant, that just means a number, it's not going to have a variable. And I'm doing long division, and it wants me to check my answer by doing multiplication. That's all this is saying. All right, so I'm going to set up my problem. I'm going to take my dividend, which is 2x squared plus 15x plus 20. And I think I'm just going to write with my finger because the pen is glitching out. All right, so I'm going to take 2x squared. Oh, I guess I have to use a pen. Okay. 2x squared plus 15x plus 20. And I'm going to divide by x plus 6. All right. So again, this is very similar to the original. We know x plus 6 went evenly into 2x squared plus 15x plus 18, which is the previous problem. So I already know this is 2 more. So I'm expecting a remainder of 2. I'm just going through the procedure again. So x plus 6, we're going to look first at the binomial, because this is a binomial. And we want to multiply x plus 6 times something. So our first term is going to be the 2x squared. And so x times, we'll need a 2x up here to get the 2x squared. So we go ahead and distribute the 2x to the x plus 6 to get 2x squared plus 12x. Okay, then I'm going to distribute my negative or subtract. It's going to cancel. Remember, I'm doing 15 minus 12x, 15x minus 12x, which is 3x plus 20. Okay, I want to multiply something times x plus 6, so my binomial starts with a 3x. So that's going to be a plus 3. Okay, this is identical to the problem above. But now when I multiply, I'm going to get 3x plus 18. And I have to subtract that. Remember, this goes in parentheses. I'm subtracting the whole thing. And 20 minus 18 is 2. So now I have the quotient of 2x plus 3 plus the remainder of 2. And that goes over my divisor, which is x plus 6. Okay, so now in this case, 2x plus 3 is not a factor of our dividend because we do have a remainder. So this 2x plus 3 is not a factor because it has a remainder. Okay, factors by definition divide into something evenly with no remainder. Okay, so I've already multiplied the 2x plus 3 times x plus 6 above. And in this case, I'm going to add the 2 to check my answer. So when I did this multiplication above, I get 2x squared plus 15x plus 18. And then when I add 2, I'll get my dividend of 2x squared plus 15x plus 20, which is a check. Okay, so it says when we divide two polynomials, we'll get another polynomial. All right, this is 2x plus 3 is called a polynomial, and the remainder. Okay, so the remainder in this case is 2, and I write it in quotient remainder form. So this is the quotient, and this is the remainder, and that's quotient remainder form. All right, for exercise 3, okay, these are a little bit different, okay, because now we have what are called incomplete polynomials. All right, if you notice from x to the fourth and then jumps to x squared, so this is kind of going to be messy when we divide. So to fix this situation, okay, we're going to insert a 0x cubed to fix this and make it a complete polynomial. Okay, because 0 times x cubed is just 0. We're not changing the value, we're just changing the appearance. Okay, I'm forewarning you, there's not a lot of space here, so you have to write small. Okay, and I'm going to start up here so I have more room. So I'm going to rewrite x to the fourth plus 0x cubed minus 4x squared minus 4x plus 8. And I'm going to divide it by x minus 1. Okay, so since I'm dividing a binomial into this polynomial, I'm going to first look at a binomial at the beginning of the polynomial, and I want to multiply my x times something to give me an x to the fourth. So my first term has to be x cubed. All right, so I'm going to take the x cubed and I'm going to divide it. I'm going to distribute it to the x minus 1, and x cubed times x is x to the fourth. That's what I want, that first matching term. And then x cubed times negative 1 is negative 1x cubed. Okay, so now I'm subtracting this. And the first terms should always cancel because you're getting them to match. So something minus itself is 0. This case, be very careful. You're doing 0 minus a negative 1. So this is actually going to turn into a positive 1 x cubed when we subtract. And then we're going to bring down the next term of negative 4x squared. All right, then we repeat. Okay, we want something times x. That's going to give us that first term of 1x cubed or x cubed. So that's going to be just x squared. And now we distribute the x squared. X squared times x is x cubed. And x squared times negative 1 is negative 1x squared. Okay, I'm going to distribute my negative, which is just basically subtracting the binomial. These will cancel out. And again, be careful. I have a negative 4 minus a negative 1. So it's the same thing as negative 4 plus 1, which is going to give me a negative 3x squared. Okay, bring down the negative 4x. And I'm looking for the term up here times the x. It gives me a negative 3x squared. So that's going to be a negative 3x. And I'm going to distribute. So I get negative 3x times x is negative 3x squared. That's my matching term I was looking for. And then negative 3x times a negative 1 is a positive 3x. Oops, it says positive 3x. All right, so I'm subtracting. These cancel. Negative 4 minus a positive 3 is negative 7x. And then I bring down my 8, positive 8. And again, I look at what term times x is negative 7x. In this case, it's going to be a negative 7. All right, so negative 7 times x is negative 7x. And negative 7 times a negative 1 is a plus 7. And then I'm going to subtract. And 8 minus 7 is 1. Okay, so in this case, okay, I'm going to get to write it in quotient remainder form. Sorry about that. I'm going to write my quotient. So my answer is going to be x cubed plus x squared minus 3x minus 7 plus, or yeah, it's a positive one, so we can say plus. If the remainder were negative, I could have put a negative sign there. And it's 1 over, okay, the remainder is always going to be over your divisor, which is x minus 1. Okay, so this is my answer, and I would say that x minus 1 is not a factor of the dividend, this x to the fourth minus 4x squared minus 4x plus 8, because there is a remainder and it does not go in evenly. All right, one more of these. All right, so this 2x cubed minus 3x plus 5, again, we can see it's called an incomplete. I should write that down. These are called incomplete polynomials. So beware of the incomplete polynomial. Okay, you'll get really confused if you don't add the extra term here. So this is my dividend. I'm going to write my divisor, x plus 3. And I'm start dividing. So, oops, I forgot to add the plus 0x squared. So plus 0x squared minus 3x plus 5. Okay, I just changed my incomplete into a complete. And, okay, so I need to ask myself what times x gives me 2x cubed? That's 2x squared. So I'm going to put that up here. And I'm going to do my multiplication. So it's going to give me 2x cubed plus 2x squared times 3 is 6x squared. Then I subtract. I'm going to make sure I put parentheses around this, or it really wouldn't be accurate. And then 0 minus 6 is negative 6 x squared. And if I didn't put that 0 there, I would end up with negative 3x plus 6x squared, and I wouldn't be able to subtract them. So that's why it's important to put the 0 there, so I have like terms. Okay, I'm going to bring down my minus 3x. This next term would have to be a negative 6x. When I distribute, I get negative 6x squared and minus 18x. Okay, if you're going to mess up, it's probably with your subtraction here. Okay, negative 3 minus a negative 18. That's the same thing as negative 3 plus 18, which is 15x. Plus, and bring down the plus 5. And then what times x is 15x? That'd be a plus 15. Distribute the 15. And I would get 15x plus 45. Let's subtract. And this cancels. And then 5 minus 45 is negative 40. So in this case, my remainder is negative 40. Okay, so I'm going to write my answer here. Like I said, I warned you that there's not going to be tons of room. So I'm going to change the color just so the answer is evident. Okay, this would be 2x squared minus 6x plus 15. And then since it's a negative 40, I could just write minus and then write my remainder over my divisor. My divisor in this case is x plus 3. Okay, and that would be my answer in quotient remainder form. Okay, so exercise 3.5, we wanted to put here. Originally, we didn't have this in our notes, but it showed up on the Regents, so we just want to give you guys some exposure to this. It tells us when we have a function p of x, and I'm just going to write it like this. Okay, this is any polynomial. Okay, it doesn't tell us what the polynomial is, but we divide it by x minus 1, and it tells us the quotient, or the answer, is x squared plus 7 plus 5 over x minus 1. So I encourage you to pause the video and see if you can figure out how would you find out the original polynomial. Okay, hopefully you've paused the video and you've thought about this. But basically, to get our original polynomial, we would just do the multiplication just like we would if we were checking our answer. So we take the divisor, we multiply it by the quotient, and then we add our remainder, and that should give us the p of x. So that's what we're going to do. We're going to take our divisor and our quotient. Okay, I'm going to write the quotient first. So x squared plus 7 times the x minus 1, and then add 5. And it wants it in standard form. So I can't just leave it like this. I have to go ahead and double distribute and combine like terms to put it in standard form. So this would be x cubed minus x squared, or minus 1x squared, whichever you prefer, plus 7x minus 7 plus 5. And then we would just combine the constants at the end for a final answer. Okay, and if I were taking a Regents, I would actually take this and divide by x minus 1 and make sure that this is correct, just to guarantee that I was doing it correctly, because I can. All right, so that was polynomial long division. We're going to finish the notes in the next lab. We're also going to split this into labs, so we'll teach you this method, but I think you've learned enough new information today. So your homework is going to be questions 3A and B. Okay, practicing your long division. It tells you here there should be a 0 remainder, so if you're not getting a 0 remainder, you're doing something wrong. And then you're also going to do number 4, all parts. This is not multiple choice. You're going to do A, B, C, D. All right, and then we'll probably save number 5 for the homework for next lesson. So copy the notes, take the notes, and do numbers 3 and 4 completely. They're not multiple choice, so I don't want to see somebody just circling an answer for number 4. And you have to show all of your work for credit. All right, and you can email me if you need any assistance. Stop the video.